sustains life on Earth. It regulates our climates, supports fisheries and coastal economies. It enables global trade and provides food and livelihoods for billions of people around the world. And yet, the ocean is changing. Rising temperatures, shifting currents, extreme weathers, and rising seas. The signs are everywhere, and the consequences are real. What if we could see it coming? What if communities, industries, and decision makers across Africa and across the world could access reliable forecasts of the ocean's next move? That capability exists. It is growing, and this course is where it begins. Welcome to this massive open online course, Fundamentals of Ocean Forecasting. This project is funded by the European Union through the Opera project in the framework of Ocean Prediction DCC, implemented by Mercator Ocean International and profused by the Gulf of Guinea's Ocean Science Summer School, UNESCO-Chaire. Over 7 modules, you will build a full picture of how modern ocean forecasting systems work. From the physics of the ocean, to the models that simulate it, to the people and industries that depends on what it tells us. Whether you're a student, a working scientist, an environmental professional, or even someone just curious about the sea, this course is for you. Ocean forecasting is not one thing. It is a chain. 7 connected steps, each building from the last. We start with the bigger picture. Module 1 introduces the full forecasting chain. Observation, models, services, and users, all connected in a continuous loop. You will see why feedback from users is what makes them improve. Then we get into the physics. Module 2 builds your understanding about the forces that drives the ocean. Circulations, tides, waves, mesoscale eddies, and the processes that shapes the marine ecosystem. This is the science that lies beneath forecasting. From there, we open up the forecasting machine itself. Module 3 takes you inside numerical ocean models, the computational engines behind every prediction. You will explore how they are built, how resolution shapes their results, and why every modeling choice matters. But a model without data is only theory. Module 4 connects models to real ocean through observations and data assimilation. Satellites measuring sea surface heights and temperatures. Argo floats drifting at depths. Mud buoys along the coasts. You will learn how these observations are collected, validated, and fused with model output, reducing uncertainty of every forecast predicted. Every forecast is only as good as what fits it. Module 5 maps the data landscape. Where do inputs come from? How do Copernicus marine products, Era 5 atmospheric forcing, and open access datasets enter the system? And how do you assess them? Producing a forecast is only half the job. Reading it is another. Module 6 teaches you on how to interpret a forecast, what it is telling you, and what it is not. This means learning how to read ocean data products such as maps, time series, vertical profiles, and anomalies. How do you identify uncertainty? How do you avoid misreading a signal? And how do you communicate ocean information clearly to non-scientists? And in the final module, we see what all of this is for. Module 7 brings the system to life through real-world applications, such as marine safety, fisheries, pollution monitoring, offshore operations, and coastal management. Through African and regional case studies, forecasting becomes what it truly is: a tool to protect lives and sustain livelihoods. 7 modules, 1 connected journey. Ocean forecasting is not only a scientific discipline. It is a tool for empowerment, preparedness, and sustainable development in a world that urgently needs it. This is your invitation to be a part of it. The ocean connects us all. Join us.